So that's what I'm going to do now, is rather quickly go through this summary of key points, just so you know that this summary exists in your tutorial package, and you might want to refer to it as you start going through the lessons. We'll go through it again at the end of the class, and it'll mean more to you then, and we'll spend a little longer time going through it at that point. Without my glasses, I won't be able to see where it is. Okay, so what pieces of spice must I use when I have a problem sitting in front of me? Well, there's not a simple answer to it. It depends on what you're trying to accomplish. Are you trying to do some scientific data analysis? Are you trying to plan an instrument pointing profile? There's lots of pieces of spice, as you've sort of seen already, and so you have to think a little bit about what pieces you'll need. Don't feel overwhelmed. You know, you've seen that the Spice Toolkit is a huge pile of software, wonderful pile, I might say. There's lots of kernels. Sometimes selecting kernels is a little bit of a challenge, although Mark is making it much easier for you folks here in Europe. Even with the size of Spice, you can do an awful lot with just 3 or 4 or 5 subroutine calls. That's one of the interesting things about Spice. That's why it's a little complicated, because a single subroutine call can do so much. So the next several charts will try to highlight some of the key points that you'll find useful. And of course, this assumes that you've downloaded the toolkit and are familiar with it, which of course is a little presumptuous at this point, but over the next day or two you will have that familiarity. And we suggest you actually think about printing out this tutorial and keeping it next to your desk when you're doing this Spice job, because we think it's useful in that sense. So, a reminder of the key subsystems. You've heard this 2 or 3 times already, but we put it in this tutorial again. We're repeating stuff where we think it's useful. This tells you about the various kernel types and what they are there for. And then on the next chart, we say, okay, for any given kernel, if you have a sense that you need to use an SPK file, somehow you've gotten that sense, you remember that, well, what subroutines from the Spice Toolkit might you want to use to access data in that kernel? Well, the top left of this chart shows you the 4 most used SPK reader subroutines. And then similarly for the other kernel types. If we look at that question kind of the opposite way, and instead you've figured out that you need to use the SPK EZR routine, and you say, well, which kernels would I need to use that routine? Well, it's pretty obvious that you would have to use an SPK file, a trajectory file, but gee, maybe there's some others that you would want to or need to use depending on what you're trying to do. And that's what this chart tells you, and this is probably these 2 charts are probably the most important charts in this presentation, because as you can kind of tell from here, just because you're reading an SPK file doesn't mean all you need is or you're using SPK EZ doesn't mean all you need is an SPK file. You may need a PCK, you may need a CK, you may need a frames kernel. So we indicate that with Y for yes, you'll definitely need it. M for maybe you'll need one, maybe not, depends on what your arguments are. And L is in the middle, so it's likely you'll need it, but it's not entirely clear. So this chart talks about the primary high-level subroutines on the left under the column module name for a bunch of the routines, and then this is just additional a second chart because we couldn't put it all on one page. So I think keep these two charts, put them under your pillow tonight and kind of memorize them, because you'll want to know that. Kernel coverage, we've already talked a little bit about this. Remember that a given kernel has data for something, often for a period of time, in some cases, other kernels, it goes forever. But you got to make sure that the data that you need for your job is in the kernels that you're using. So your kernels must contain data for the objects of interest, particularly if you're using an SPK or CK file. And sometimes you need multiple SPKs to cover all of the objects of interest. It must contain data covering the time span of interest. Probably the second biggest problem that students encounter is trying to compute something using an SPK file that doesn't cover the time frame that you're interested in. So you have to really pay attention to the start and stop times for SPK and CK files. Also, watch out for data gaps. This is something that isn't maybe all that familiar. C kernels often have gaps in the data. So even if a C kernel summary says it goes from time 1 to time 2, there often are gaps in the middle of that file. And if there is a data gap, there's nothing you can do about it. And you need, other than know about it, and so not get upset because you couldn't get an answer. Now, in fact, there really is something you can do about it in some cases, and Boris will talk about that later on. But pay attention to data gaps. SPK files tend to be much more continuous, but even they could have data gaps. We try very hard on the production side to not have that, but it's possible that there are data gaps in an SPK file as well. So be aware of this notion of data gaps. Make sure you have loaded all the kernel types that you need. You look back at the two previous charts, and they show that there are often some extra kernels that maybe you wouldn't think you need, but you really do need. And make sure that you have loaded the kernel's property. We talked about the precedence rule a little bit earlier, and so the last loaded kernel of a binary type takes precedence over an earlier loaded kernel. And sometimes that's very, very important. So you have to be aware of that and think about that. What kernels are available? Well, it depends on the mission. And as you could tell between what we've talked about and what Mark talked about, there's different coverage of kernels. There's different kinds of kernels. Sometimes there's meta-kernels, sometimes not. In the NASA situation, there's these three generic categories. Mission operations kernels, this is the big kahuna of kernel collections where all of the operational kernels are placed from day one on till the end of the mission. So the good news is everything is there. The bad news is everything is there, and you have to sort through it manually to try and find the right ones. Again, Mark, with his meta-kernels for the operations on the ESA missions, has gone a long way to try and make it much easier for you guys on European missions to use the operational kernels. Then there's the archived kernels, whether it's PDS or PSA, and here we tend to match exactly across European missions because we mirror Mark's archive. Those are much easier to use, at least on the NASA side, because we do have very good meta-kernels produced for the archives. And then there's the generic kernels. These are things like a planet ephemeris or the planetary constants, most planetary constants kernels that are independent of any particular mission. So in NASA, the DE-430 planetary ephemeris applies to any mission, in every mission. It's not just for Mars Odyssey or Juno. And as I say here, the situation may be similar for non-JPL missions, but it's up to each individual institution, whether it's ESA or Russia or Japan or India. They all have their own variations of what they do. So how can you find useful toolkit modules? Well, review the previous charts, as I keep saying. And look at the tutorials. You know, you're going to have these tutorials available to you after this class. Look at the most used APIs document that Boris referenced a moment ago. That gives a quick summary of what the top 100 or so most often used APIs do. Search the permuted index. If you can think of a word, you know, like convert or frames or SVK read, that document can help you find all of the modules that pertain to that word or that set of words. And last but not least, read the so-called required reading documents. Now, those are big, long, tough technical documents. We know most people do not read them, even though we call them required reading. But they're there as sort of the real underlying reference to give the most amount of detail if you haven't found information in some other document. How can you understand how to use these modules? Well, as Boris just told you moments ago, look at the header. That is where all of the user-oriented specific information for that particular module exists. And it's available in text and HTML. Many of them, especially the more modern ones, contain working code examples and long descriptions of inputs and outputs. Again, the reference documentation, the required reading documents will help you better and further understand how to use particular modules. These tutorials have a few examples in them, and in fact, a couple of tutorials at the very end that we won't present but are in the backup section are a fairly substantial problem that is played out in Fortran, C, MATLAB, and IDL, and that might be a useful tutorial to look at. And we talked about the sales training materials. Well, you're seeing all of the training materials right here in this class. Again, the headers contain working examples. Well, I guess we pretty much said everything that we show on this slide. So that's the end of that preview of key points. And again, we'll sort of go through this a little bit more towards the end of the class. But I think keep that tutorial, you know, on your dock someplace so you could look at it.